there everybody, it's Max here again with you, Max, and today we got another short video for you. We're going to be showing you how to use feature tracking on the EinScan Rigil's laser mode. We've had a lot of requests to talk about this feature and how to use it on the Rigil, so let's go ahead and dive right in and see what we're working with.
The Rigil's laser scanning is very powerful. However, the need for markers makes its application tedious and time-consuming, especially with larger subjects. Luckily, Shining 3D has been pushing feature tracking to laser modes for their hybrid light scanners, allowing scanners to leverage their infrared mode's feature alignment capabilities while collecting data with their more detailed laser scanning component. This allows you to skip markers entirely for many subjects you would want to scan with the laser mode. But not all subjects that you would previously use markers with can be scanned using this method. Your subject must have rich geometric details throughout the scan in order to maintain tracking. So subjects like car body panels and straight pipes would not be ideal. This car cylinder block is an example of a good subject that we'll be testing the feature on today. So how do you use it? Many Rigil users might be confused to see this feature missing in normal operation. Well, it's actually only possible in the PC assisted mode. So we'll start out by connecting our scanner first. I'm going to use the built-in hotspot for convenience, but you can also connect via Wi-Fi or the USB-C cable. Also ensure that your batteries are fully charged, as this feature draws a lot of power and won't operate under 25% battery either. Let's go ahead and start a new laser mode project. Now all we have to do is select feature alignment. Many users will find the scanning process in this mode more difficult to use than with marker tracking. So before you dive in, let's talk about scanning with feature alignment. Using feature alignment, your settings play a much bigger role on how reliable your tracking is, as your scan data itself is the point of reference for your scanner, rather than the markers. Let's start by choosing an appropriate surface type. My object is reflective, and then adjust your brightness here so that your laser lines are clear and well defined in the camera view window. Don't be afraid to play around to find the best settings if the data isn't good enough for the alignment. Watch out for patterns and symmetry that could confuse the scanner, or else you could end up with overlapping ghost data. If you do see this start to happen, immediately stop the scan and cut away the unwanted artifacts using your data editing tools. New geometry can also be added to break symmetry and get around corners, like a prop or a bit of putty to stick to surfaces. Keep your scanner focused on rich and unique geometry, moving to new areas slowly, paying attention to any of the features that could cause trouble. Going around sharp angles requires slow and steady movement, as well as awareness of what the scanner is looking at and whether or not it has enough features to maintain tracking as the new area is made visible to both cameras. The both cameras part is very important, as both cameras must see the geometry in order for it to be recognized by the scanner.
Alright guys, that's about it for this one. I hope you enjoyed and are excited to use feature tracking on the EinScan Rigil's laser mode. And if you're interested in your own EinScan Rigil, make sure you head to emax.com for amazing deals, free training, and accessories. Thanks for watching. Bye.